In this last exercise of the chapter, we're going to develop methods for finding the minimum and maximum values in a binary search tree. Looking at a binary search tree, you can see that it's very easy to find the minimum and maximum values. To find the minimum value, you simply travel down the left of a tree until you reach the last node. To find the maximum value, you simply travel down the right nodes of the tree until you reach the last right node. So developing the methods will involve simply doing that, following the left or right nodes until you're out of nodes to follow. So let's develop the methods. We'll do minimum first. We'll call it min. First thing we'll do is we'll create a node and assign it to the root. That's where we always start, is at the root. And then we're going to simply say while current.left is not equal to null. In other words, while there's yet another left child node to travel down, travel to the next left node by writing current equals current.left, which will move us one more node down to the left. We'll stop when the leftmost node does not have a left child, because that will be false, or current.left will indeed be equal to null. So then at that point, we can simply return the data that's stored in that node. That will be the minimum value. To find the maximum value, we'll call our method max, and we'll simply travel the other way. So while current.right is not equal to null, move to the next right child node. And when you've reached the last one, return the data, or get data. Just like so. That's all there is to it. So we'll save the file, compile it. Now we'll go to our B-tree program. We'll use our same data that we used before. And we'll call min right here, like so. And then for the maximum value, and that should be all we need. So we'll save the file, back to our command prompt, compile it, and run it. The minimum value is 1, the maximum value is 14. Let's take a look at our code again. And indeed, minimum is 1, maximum is 14. So, again, one of the great advantages of binary search trees is making it very easy to find data. No matter how large the tree is, it's a minimum number of jumps, if you will, by just consistently traveling down the left or the right. It would be so much easier than if the data was in a linear format. Now, of course, if you're using some sort of data structure that you can sort, then it's much easier to find the minimum and maximum values, because the minimum value is at the beginning of the sorted collection and the maximum value is at the end. But for data that cannot be sorted, that's simply collected using a binary search tree, works great. So with that, we're finished with this exercise, and that wraps up this chapter.